Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is actually a comparative study between alkene versus alkyne. So you can see this molecule, it is actually having a terminal alkyne and terminal alkene and terminal alkyne. So here it first reacted with this bromine 1 mole, and what is the product you have to say. Here 4 options are provided and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. And don't worry, after some time you will get the right answer. So I believe you have tried by yourself, so it's my turn to give you the right answer. But before going to details, very brief discussion. Actually it's a pretty easy problem, student. So this is actually electrophilic addition of bromine across pi bond. This is a simple thing, and we know in presence of this pi bond this bromine could be polarized as delta plus and delta minus, and these delta plus bromine is actually the electrophilic center, means this pi bond will attack it here. Now question, where the reaction will happen. So you can see here the first, these alkene double bond act as electrophile, this bromine delta plus, and ultimately this bromine leaves. So after first step it produces this. So after first step, if I say that this is this, and you can consider that this is the bromine and here the positive charge. Obviously this bromine has 3 lone pairs of electron, so it will attack here, and in this way this 3-member ring or bridge bromonium cation or bridge bromonium ion is produced. Now obviously along with this Br plus, means this cationic organic moiety, there is bromine anion also, and these bromide anion attacks via SN2 fashion opens up these 3-member ring. Okay, so through this SN2 type reaction it produces this anti-type 1,2-dibromo product or 1,2-dibromo compound or vicinal dibromide. Now here this attack happens from the back side, that's why this bromine to bromine orientation is anti to each other. But a question is how this syn product is equivalent to this anti product. Okay, so now this is because here if you look at, it is a CC single bond and CC rotation is allowed. So that's how this rotates and produces this. Actually this is the product, but we have to think one point, what is given in our question 2. So what is the answer? In this case answer is option C. Now if this question appear in your exam less than 30 seconds, how could you answer? Student, remember, you need to remember only one point, that for this bromine addition, means this halogen addition, these alkenes are more reactive than alkyne. Okay, why? Because the 3-member ring strain. So if you know this information, this problem is pretty enough, because in between there is an sp3 carbon, so these two pi bonds are not in conjugation, so it's an easy. So if you know this information, finally you will get directly the final product. Otherwise if you think from back side, if you look at this bromine only given, so allyl bromination not possible. Another thing, means other 2 options are this addition of bromine in the triple bond. Simple, bromine addition to pi bond happens through bridge bromonium ion. So if this bridge bromonium ion happens in this case of alkene, the bridge bromonium ion is more strained, because here you can say 3-member, but there is a double bond or pi bond, so more strain. So consequently this A gone, B gone, C is the right answer. Now, so in conclusion, what you have learned today, that bromination of alkene or alkyne is electrophilic addition reaction to the double bond or pi bond, where bromine acts as electrophile and pi bond acts as the nucleophile. Now in this reaction, 3-member ring, that is bridge bromonium ion, is produced as intermediate, and these 3-member ring with 1 double bond is more strained than saturated counterpart. I mean here indicating that the bridge bromonium ion produced from the bromination of alkyne is more strained compared to alkene. And actually from electron density point of view, if you think that alkyne is more reactive because it has 2 pi bonds, but in this case the TS is more energetic because it is associated with angle strain. And at the end, bromine addition to alkene is a trans or anti in nature. However, they may come in same direction by CC rotation because sp3 carbon carbon bond rotation is allowed. So this is the end of discussion. I believe this video may be useful. I thank you everyone for watching this video. If you really consider the content of this channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Bye bye.